So let's move to the scattering parameters or metrics. So we can call metrics and parameter, either way is okay. And then in brief, we call S parameters for this, so scattering metrics. So this is a most important parameter that is used in microwave engineering. So you need to kind of understand correctly. So the reason why S parameter is important is actually we learn Z and Y parameters, right? But these parameters are not used in in microwave engineering popularly. So the reason is, so for example, for the filter case, right, two-port case. So let's say we have two-port, and then if we want to measure G1, let's say G21 or Y21. So one is source, right? So let's say this is one is source, and then to measure Z and Y parameter, we should make open circuit or short circuit, right? So I mean, ideally we can open and short, but as I mentioned, this line is always transmission line, right? So transmission line is coaxial cable. One common example is coaxial cable, and then microstrip line, right? So to make short and open in microwave engineering, reason is very complicated, very difficult, because so this is a coaxial cable, right? So open means we just kinda, this is signal line, this is ground, right? So we just kinda open it without putting anything, but because microwave signal comes and then some part will radiate, and then this ground, and then capacitance this ground has some capacitance, parasitic capacitance. So there's no idea there's no idea open. And also let's think about short circuit means this is signal and the ground, right? Short means transmission line is short, right? So we can short like this, right? But even though we short, this is not completely short, because this kind of physical connection will make some inductance. So there is no idea open and short in RF or microwave frequency. So this Y and Z parameter in reality, right? So if we want to measure Z21 and G21 and Y21 of this filter, then we should realize open and short circuit. But even though we make coaxial cable like this, or for open, or microstrip line for short, this is not real open and short, right? So, and the microstrip line, if we open, we just can open, right, without any connection. But this also has some capacitance between this, even though it's open, and then some radiation happens. Some portion will be radiates to the air. So that's why we don't use open and Y and Z parameter. And then about this kind of amplifier, so to measure G21, we need to connect source, and then we need to open or short, right? But if we connect open and short to the amplifier, then amplifier will oscillate. So this amplifier will not work as we desired. So this is another reason. So for this case, amplifier will oscillate. on, open, and short. So that's why we don't use z and y parameters. And then the most important parameter we use is scattering parameter. So scattering parameter is used so kind of relative measurement. So what does it mean is, let's say we have a two-port filter, right? And then two-port filter, and then we have let's work with this kind of two-port simple filter. So for this filter, so as I mentioned, we can make two lines for one port and two lines one port. So one line is for incident voltage, and this is reflected voltage from port 1. This is incident voltage from port 2. Right, we can like this. So if we define AN for V1 plus divided by Z0 square root of Z0, and then V1 is V1 minus divided by square root of Z0. So A1 and B1 is normalized incident and reflected waves. Let's say voltage. This pen doesn't work efficiently even though I try to erase. So this is incident and reflected voltages, but this is normalized, right? With this square root of Z0. So A means incident and B is reflected voltage. So we can simply make A1, B1, A2, B2. So this is incident wave, this is reflected, incident, reflected. So S parameter can be defined as this. This is a reflected wave, and then we have some matrix between this, and this is incident voltage, right? And then so we call S11, S12, S21, S22. So this is a scattering parameter. Matrix, or you can say scattering parameters. So B1, just do the matrix calculation. S12, A2. B2 is S21, A1, S22, A2, right? So to calculate S11, why this is happening? Yeah, to calculate S11, so B1 divided by A1, right? When A2 is 0, right? So how to make A2 0, right? So what does it mean is wave. So let's say we connect port 1 is connected to source. It's port 2, right? So wave is start incident, and then some wave will flow this way, and then some wave will reflect it back, and then it will generate this voltage, right? This is A2. So to make A2 is 0, then we should terminate this transmission line with Z0 load, impedance with Z0, so that wave start incident and some wave will be flow to the port 2, and then because this Z0 load is matched to this transmission line, so there is no reflection, right? No reflection, so that A2 is becomes 0. So what does it mean is port 2 is matched, impedance matched, right? So for this S parameter, we don't need to make open and short, we just put impedance matching, right? What about S12? P1 to get this, P1 divided by A2, and then A1 should be 0, right? So what does it mean is port 2 is matched. For this case, right, S12 means 2 is a source actually. So 2 is source. So when 2 is connected with the source, to make A1 0, we need to match port 1. So this is what I mean, right? So port 2 is source, and then this is transmission line, so we should terminate with Z0, so that some wave is start flowing, and then from after filter some wave come to here, right? And then to make this A1 0, then we shouldn't have any reflection here. So to do that, port 1 should be matched, impedance matched, right? So this is how we measure S11 and S12. So the only thing we need to do is we should kind of use this matched load, Z0 ohm, impedance, resistance, and then matched, right, to calculate S11, S12. So in general, right, if we have some network, we have so many ports, and port 1 and 2, then we can generalize this one to B1, B1, so B1 to Bn, so A1 to A1 is incident, normalized incident, B is a normalized reflected voltage, right? So S11, S12, S1n, then Sn1 to the Snn, right? So B1 is S11A1, S12 A2, S1n AN. Right, so to measure S11, right? So to measure S11 for this case, P1, so it's kind of basically relative measurement, right? Incident wave to the reflected wave, but then A2 to AN should be 0. What that means is all other ports should be matched, right, to Z0. So all the wave incident to this, all the ports become 0, right? So this is a S parameter. So for in general, Sij, relative measurement from incident a J, so J is a source, J is source, and then Pi. Then AK is 0 for K is not same as J. Similar to Y and Z parameters. So Sij can be found by injecting the incident voltage to port J, right? Port J source, and for this A J, right? To port J and measure the reflected wave. Coming out of port I. When all ports are matched. So it's 0, right? So this is general term. This is breaking. So as I show S11 is B1 divided by A1 when A2 to AN are 0 or matched, right? So this is a reflection coefficient at port 1. So if we make some example from diplexer with port 3 ports. So for this case, right, for reflection S11 we match Z0 ohm on port 2, port 3, so that we connect source. If we measure incident wave A1 and reflect wave B1, then this is reflection, right? Incoming to reflection, so this is reflection coefficient. So basically in S parameter, S11 means reflection coefficient of some specific ports. So SJJ means BJ and then AJ. So AK should be 0 for K is not J, right? So this is a reflection J. So reflection coefficient at port J, right? And the S21 is also very important parameter. So B2 is 81. A K is 0 for K is not 1. So let's So if we start from filter, so two-port measurement. So two-port measurement should have S21, right? S21 means port 1 and port 2. Port 2 should be terminated to G0, right? And then if incident wave comes, and then some wave will be come out to this B2, right? In port 2. So the ratio between A1 and B2 is S21. So what does it mean? So if wave incident, some wave will be shown in the port 2. That means how much transmission, right? Transmission happen. So this is a transmission coefficient from port 2 to port 1. Port 1 to 2. So you should know that port 1 to 2. So this way, right? So if we say port S12 means from port 2 and port 1. So normally we use a port 1 as an input port, so that S21 is very common for transmission coefficient calculation. So S12 is source is port 2, right? So this is not that common. So this S21 is common because S21 means transmission coefficient from port 1 to 2, because port 1 is normally used input port, right? Which is connected to the source. So S21 is very common to measure transmission coefficient of some structure, right? For this kind of diplex case, right? So port 2 and port 3 or match to G0, right? And then if some wave comes B2, so if you take ratio between A1 and B2, that will determine S21 for this kind of three-port network. This is two-port network. So lastly, reciprocal network. So it was represented by this, right? And the Yij is Yji. That's parameter. S also same feature. So Sij, Sji. So S12, if S12 is same as S21, so we call reciprocal network, right? So for this case, filter, right? So if for filter, so S21 means when port 1 is source, right? So how much signal transmit from port 1 and port 2 when this port 2 is matched. But S12 is this way, right? This is G0 ohm, and then so it's A2 and then B1, right? So this is a S12 measurement, right? So A1 is 0, right, for this case. So S21 and S12 are same. That means this circuit or network are reciprocal, right? So basically all the filter, as I said, filter or resistor, two-port network, capacitance, passive network is follow this reciprocal network, but amplifier, right? So it's not reciprocal. It's not independent from source location. Right. So let's kind of move on to another feature of S parameter.